This is problem 1 on practice exam 3 of chapter 1 in the book Problem Solving Guide for Differential and Integral Calculus. We have a birthday cake, height h and radius r. The frosted area, which is the curved side and the top, not the bottom. You don't frost the bottom. Pi r squared, which is the circular top, and 2 pi r h, which is the curved side of the cake. That's the total frosted area of the cake. So derive the difference equation for the area of a cylindrical cake that is frosted if the radius is different from r by delta r. That's part A, and we're going to focus on that first. So there's two cakes, one that has radius r and one that has a radius of r plus delta r. It's a bigger cake, has a bigger radius. So we want to find the difference in the frosted area. We want to relate the frosted area, the change in the frosted area, to the change in the radius for a constant h. So if the cake has radius r and height h, the area is just this normal equation right here. If it's different by delta r, we have a different area, and that area is a plus delta a, and we just plug in r plus delta r for the radius of the cake. And we can subtract these two expressions. This is the area of the cake with the radius r. This is the area of the cake with the radius r plus delta r. And we get this big mess. We just plug them in. And we can do some algebra to make it look a little bit nicer. And we get this. That's the answer for delta A, the difference between the frosted area of two cakes. One has radius r, one has radius r plus delta r, is that expression. Now we can tackle part B, derive the difference equation for the area of a cylindrical cake that is frosted if the height is different by delta h and the radius is constant. So now we're changing the height. If we just change the height, the top area isn't going to change at all. It's still pi r squared. So the frosted area of the cake, that's the normal equation. That's the normal equation for the frosted area. Then we're going to change the height a little bit, and that's only this part right here. So if we subtract these two, the pi r squared is going to go away, not surprisingly, and we just get 2 pi r delta h. If we change the height by a little bit, we have this little strip that we have to frost. That's the only difference, and that area is 2 pi r delta h. Part C, now we're going to change them both. So we change the radius, we change the height. What's the change in the frosted area? There's going to be a lot of algebra here, but that's what happens when you do science. You have to deal with algebra. Don't fret. So here's where we start. Now we're going to change the radius and the height. You just got to be careful. All right, and we get this equation. Now we're going to have to multiply this out and subtract them. So here we multiplied it out. We FOILed it, first outers, inners, lasts. So the difference in the area is this. Big expression. That's the answer. Now on to part D. Now we've got to put some numbers in. It's got a height of 4 inches and a radius of 4 inches. What's the change in the area if the radius is increased from 4 to 4 1/8 inches? We increase it by 1/8 of an inch, the radius, and we keep the height constant. So we have an expression, part A. We could plug it in. We plug in 4 inches for r. We plug in 4 1/8 inch. We plug in 1/8 of an inch for delta r. There's the r, there's the delta r, there's delta r squared, there's delta r, and the h is still 4 inches. And we get 6 1/3 inches, almost 6 1/3 inches, just under 6 1/3 inches. So if we increase the radius by 1/8 of an inch, we need 6 1/3 square inches of frosting, more frosting, to frost that cake. We have to put more on the side, and we have to put more on the top because the top got bigger. We can check this, and you should always check it using the normal equation twice. We can plug in 4 inches. That's where we start. And we can calculate the frosted area, 150.7964 square inches, the frosted cake. Now we're going to plug in 4 1/8 inch for the radius. There's the normal equation. And we get 157.1288 inches. And if we subtract these two, we get the difference in the frosted area. And it's the same as we got with the difference equation as we expected. Now we can tackle part E. It's got a height of 4 inches and a radius of 4 inches. Now we're going to change the height. So the frosted area remains the same when the radius is increased from 4 inches to 4 1/8 inches. So we're going to make the radius bigger, but we want the frosted area to be the same, which means we're going to have to shrink the height. So delta A is going to be 0 for the frosted area to remain the same. So we have this big expression when both are changed. Here it is. We want delta A to be 0. Our only unknown is delta H. How does the height have to change? So the total change in area is 0 when the radius is increased from 4 inches to 4 1/8 inch. So we have R, it's 4 inches. Delta R is 1.125 inches. H is 4 inches. The only unknown is delta H. Delta A is 0. We have one equation and one unknown, so we know we can do it. We just have to be careful. So this is delta A, and it's 0. This is the first term in the square brackets. That's this term. And the second term in square brackets is this term. Now, we just got to grit our teeth, put on our math hat, and do the work carefully without making a mistake. So we have two terms in square brackets, this one, and this one, and this one. The first one we can calculate. Get a number for it, 3.1968 square inches. And the next one has to be minus that. All right. We combined the two terms with the delta H in it, and we got this. So this must be minus that area if the total area of the cake doesn't change. So now we can do some algebra and solve for delta H. Putting the 2 pi in there. On the left-hand side, we get this. Solving for delta H, we get a minus about 1/4 inch. If we drop the height by 1/4 inch, increase the area by 1/8 inch, it's about the same. Frosted area. Now, we should check this. We should check it. So, our height was 4 inches, and it dropped by 0.2443, which means now the height is 3.7557 inches. And we increased the area, the radius, from 4 to 4 1/8. And we can calculate. We can use the normal equation to calculate. We have the height and the radius. We can calculate it. We just plug in the numbers, and we get 150.796, and that's the same area we had for 4 and 4. And that was just problem 1 on this test. Yikes.